recording again. Here we go. This is now the second part, and we're going to talk about machining this hole. So we've just demonstrated the layout of the hole, and this hole here says 1/2 inch diameter through. What do you suppose that means? That that this is a hole, and we see that by a round surface, a round solid line, and we see dashed lines, and that hole goes all the way through our part. Its diameter, when you measure across, the widest point is 1/2 inch, 0.500. So that involves a couple of things. You think, well, that's pretty easy, just drill a hole, get a 1/2 inch drill, drill a hole. Well, the difference between this and something like wood is that it's steel. And a 1/2 inch diameter is a pretty large diameter drill. There it is, right there. Now what happens is if I were to just take this and try to hit that center line, there's just no way I can perfectly find that intersection by just taking this blunt drill and just all of a sudden driving it in there. You'll never quite get it. If you see how I poked it, you'll always miss it. So what we do is kind of in a rule, when we're dealing with steel and we have a hole that is somewhere around a 1/2 inch diameter or bigger, we first of all create what's called a pilot hole. So you plan to make a smaller diameter hole through that intersection. But then you run into the same problem. So what I have is I planned, okay, I'm going to get a 1/4 inch drill, 1/4 inch. That's about half of the diameter of this. And that's usually a pretty common drill size. You'll have it everywhere. We could take a 1/4 inch drill and kind of try to eyeball that intersection, drill a smaller hole, and then come back and drill that one. That's generally what you want to do. You want to take a pilot hole or a step drill that is smaller than your 1/2 inch or greater, and then drill that first, and then you put this one in, and then it'll just follow the existing hole. Problem is, if you try to plunge this into a straight flat face, the drill might be off a little bit. So what we're going to do is, first of all, we are going to plan on using what's called a center drill. This is a combination drill right here, and if you'll notice, it's a short and stubby little tool. It has a very small diameter at the top, has like one cutting flute. Its job is to get you started right at that intersection, and you bring in this tip until it moves up the side. So the center drill looks kind of like this. I'll blow it up real big. Okay, it's short and it's stubby, so it's not going to wander around when you try to plunge it in. What you want to do is you want to take it to a depth and run it about 2/3 of the way up its face. Just a rule of thumb. What you're going to do is you're going to plan to make this thing go in 2/3 up the way at the face. You don't want to bury this in your material, but just 2/3 up the side. But before we do that, what we want to do is we want to give the center drill a little bit of help. So we're going to do that by, and I'm working, if you notice, from the largest drill to the first step. I'm working backwards. You're going to take two tools. One is called a prick punch. You'll see that it has a very sharp little point. This is a combination scribe and a prick punch. And then you're going to come and use what's called a center punch. You'll see it has a little bit of a wider angle at the tip of it. Okay? So what we do is, with your practiced eyeball, you're going to put the sharper tool right at that intersection, and you're going to try to get it right on top. You're going to give it one tap with a hammer. Then you take your center punch, find that hole that you just made, one more tap with a hammer. Not on this surface, though, please. Okay. And then you can come back and center drill, 1/4 inch drill, 1/2 inch drill. All these will then follow nicely the predecessor's hole. This gives it a good start, and because it's got an angle, it will prevent this wobbling or walking away. It'll catch it and bring it down. And then this one, of course, catches that hole. Now what you're going to find around the shop is, for the first couple projects, you're going to have these yellow bins. And that bin will generally say semi-precision, it'll say the class, and it'll also say the part number, 1001. And then we'll have those couple of tools in there. So please, if you find it, use it, but always put the tools back in the kit, all right? A lot of times people, oh, I need a half-inch drill, so they'll just take it from the kit. Well, you know, the problem is it never finds its way back. So the kit should be in pretty good shape, and you'd be able to you know, use it reliably, and the people after you can use it reliably too. All right, so our next step will be to do the quick punch, and then we'll take it to the drill press. So in our tool cabinet, we'll have a punch. And what you want to use is you want to use a steel hammer on this. You don't need a real big one, but what I'm going to do is I'm going to go back there and do it. And I'm going to have the camera follow me. But you get the idea of doing the punch. So actually, I'll do it right behind you guys. There's a big wooden block behind you right there. And this is quite simple. All we do is on a workbench, and now this is where it takes a little practice. My eyes aren't so good anymore, and then it's a good solid, but one time only. If you go and pound this like a nail, the thing is going to bounce off on you. So now we've got a good start, and we are going to now finish this hole with a center punch. One tap. Now we've got a nice start. And you can see that the center punch just slides right in there now. So what's going to happen is that center drill is going to walk right into that hole. What we're hoping you can hold is plus or minus 15 thousandths, 0.015, which is 1/64 of an inch. Okay? So let's pause recording for a minute, and yeah, we'll actually leave it running because I don't know how to pause it, believe it or not. That's okay. We'll leave it running and I'll edit that out. Tools go back, of course. Because we don't need these hand tools anymore. Next stop, back room on the drill press. So I'm going to take our kit, my part, my drawing, and my camera. Quentin, can you grab these, please? Thanks.
When I do this project myself, do you want me to use a drill press, or can I use a mill?
Well, I want you to use,
Well, I've used
if you remember how to edge find and everything on the mill, but to the purpose of this class is to do it without that kind of help.
Yeah. Oh, I was just curious because I'm using drill press. You know,
Yeah.
So I had to insure it again. I don't have my name figured anymore.
but it was just out of curiosity.
Yeah. So,
I mean, it's fixable, but it's still, like, I didn't have insurance.
okay, we're still recording. I still have sound. Here is our brand new drill press. Nice clausing. This should have been put back in the tool room. But what you'll see what we have here is something called a cam lock vise. Okay. This is a standard drill chuck. All right. This is only used for holding drills and center drills. You'll be doing other things like reaming and tapping. So you would put what we call reamers in here, but tapping you're going to do by hand, making threads, you know, so you can do screws. But this first one doesn't require a thread, but the second part does. So what you're going to do to make the first part is we're just going to go now, and again, cleanliness. I don't think I have any. Oh yeah, here we go. Always, always, always. And then, you know, generally part of your cleanup should be to brush down these tables. See all these little chips? They won't do us any good. And what you want to do is you want to slide the vise along the table here, just like you did when you loaded them up on the milling machines, right? We want to make sure there's no little pieces underneath it. Now what we have here, you should always have this one part here, and this is a stop that, because we're drilling free, this drill vise is going to be sitting here free like this. and it's going to tend to want to spin if the drill catches. So this is there to stop it from catching and spinning. All right, but this is how you're going to handle the drill. And the way the vise works is it just slides along these little rails here. You want to clean the jaws, and then you would lock your piece in like that. So if you hand me my piece there, all we're going to do, and you want to get in the habit of taking your datum edge, and all vices have a solid or non-movable face, and all of them have a movable face. You want your datum edges to be against the solid edges of the vise. So notice I'm just sliding it along there, making sure it holds, and then we just push down, and now this piece is held in the vise good enough. So first tool up is our center drill. That goes into the chuck. Gets just snugged up with this chuck key. That can go in the bin there. And now we want to turn on the drill. Notice we have a high and a low. And you have a little wheel here that you will have an indicator here. And depending on if you're in low or high, you'll have a small number like 150 and a major large number like 300. The middle number does not apply to this machine. So if I select high, for example, and my indicator's right here, okay, I'm going to go with this right here. This should be moved only with the spindle running. Notice the spindle is running clockwise, right? As I'm looking down on it, it's going clockwise. That's really important because every tool we have, be it a drill, an end mill, a reamer, a center drill, always works going clockwise. So now I'm running at about 300 RPM. If I turn it off, and now I go to the low, notice it's going slower. It's going at the lowest number at 150 RPM. So what we want to do for this job is we want to have roughly 400 RPM, or rather 500 will be good for this. Now notice how that is wobbling down there. These vices these chucks kind of take a beating, so that means the jaws are not evenly applying pressure on it. So what you probably want to do, or what you could do, is you could take it, you loosen it a little, and then try to reseat it so that, you know, and it would have been helpful if I had gone and you opened this up all the way. Sometimes little chips get in there, so if there's a little chip on one of the jaws, you certainly want to make sure that that's clean. And then this is a pretty old chuck, I can see. A lot of them are in need of rebuilding, but it'll work okay. So I'm going to come down again, and I'm going to just tighten that. And you'll see now it's running much more true, right? So I'm in the high range. I don't feel like I tightened that up enough, so I'm just going to give it one more little spin. It doesn't have to be super tight, you know, because that'll bend everything up. But it has to be snug, let's put it that way. So now we're ready to start drilling. And the way you use this is we simply turn on the machine, and what I'm going to do, I'm going to kind of step over to this side here, and I'm going to make sure that the tool can go down deep enough. You'll notice we're hitting a stop here, right? So the tool can't get in deep enough. So what I want to do is turn this off. You should not have spindles running when you make adjustments on the machine. You can either move this up, this stop here, or you can move the table closer. So what we have here is a kind of a lock nut, and the table is now loose, and you can crank it up closer, and then lock your table down again. And now you'll see that we can, maybe through a combination, that's much deeper than we're actually going to go with this tool, but you'll see that we have probably not enough room to make a tool change, so we might need to lower the table again, because when I put that 1/2-inch drill in, it's going to be too long for this. So just a matter of bouncing it around a little bit. But what we'll do is we'll now turn it on high, and what you're going to do once you come on over here, what you do is you kind of bring it close, have your hand over there, kind of let it get started by eye, and let the tool find that little hole. Did you see how it kind of jerked around? I just gently came down with it. Now you see it's right over the hole. And now we can just apply slight pressure and make our first center drilled hole. Now there's little brushes around here, but remember, don't use your fingers to do this stuff because there should be brushes, or I got a piece of paper here in my hand. So now you can see the kind of hole that's left. All right, and now we've got a good start. And it looks like I hit it pretty good. We'll see when we measure. I guess my eyes aren't so good anymore. I might have not had that right on the intersection.
You gotta be pretty close. That's the whole point.
There's our hole. Yeah. So now what we want to do, next tool goes in. So our 1/4-inch step drill can go in. Just throw that back in the bin and yeah, lower the table a bit. Thank you. Yeah, give her a little more, a couple more cranks, then I think we'll be plenty. That's good. That's good. And now we're going to lock this drill in place. This you normally would leave in there, but I wanted you to see the holes. But it's the same. Make sure everything's clean. Put it in, down, high speed. 500 should be okay. We're at 500 now. And the way you want to drill when you're drilling steel, again, a little different than wood, is that you want to let the drill find its way into the existing hole. But now what you want to do is you want to drill it, back off on it. Okay? This is called peck drilling. And what you're doing is, you see how that little chip comes out? You're breaking that off, because that can get jammed up in there, and you're making it a whole lot easier. Now, we're doing what's called cutting it dry. So we are not using any kind of coolant or lubricant to cut. This is mild steel, so you don't really need it. And what we're doing is just working our way. We could probably have gone a little faster. That would have made this cut a little easier. But now you'll kind of feel it resisting you. What's happening is we're ready to break through the bottom. And when it breaks through the bottom, what you do is you ease up pressure and then just slowly bring it down. And then you'll feel it break through. Because what's happening is the drill is starting to break through the last of the material, and there's these little sharp edges on the material, and that's catching your drill. If you go too fast and just hit that really hard, it will tend to possibly break a smaller drill. So you'll actually feel yourself drilling, then all of a sudden it'll be resisting. So what you do is you just ease up on the pressure, and then, why don't you take it out, put in your half-inch diameter drill. So what we can do is, just move that out of the way. You can probably get that up in there without needing to. Now you also want to make a habit early on. There we go, okay. We want to make a habit early on. You want to always check these diameters. So what you're going to do is you're going to get your caliper and you're going to hold it across the widest part of the drill here, and you're going to measure. In fact, Quentin, would you mind, I left the caliper on the inspection stone. Would you mind getting that? The dial caliper. That's good enough. Don't trust the kit. And sometimes we use multiple drills that are almost the same size, but they'll all have different sizes. So what we do is always try to make a habit of double checking what's in the kit, So we're going to measure across what are called the lips on these little faces here. That's the widest part of the drill. Or in the case of this type of drill, this shank, this is called the shank, should be the same diameter as that. So if we have a caliper that you should keep with you now, and you go and measure, you put it on, and you'll see that this one is just a hair under 1/4 inch, which for this job it's okay. But again, these calipers need to be clean, and if you measure there, it's about 1/1000 under. Or what I prefer to do is right across the face. See, it's right at 250. And here is how I'm holding. You see how it's right in there? And what I do is I gently turn it, and you'll see that it opens up, and then it'll start shrinking down again. So it's just a little matter of practice. And then you can also do that on here. So, you know, this part of the drill is going to be smaller. But you can hit the shank, and you'll see it's right there, right at about 500. Or across the cutting lips, which means right about there, and you'll see it's right on 500. Make it a habit of doing that, because on other projects we do, the holes, the size is going to matter. When you're reaming, it has to be a very specific size. When you're threading, it has to be a very specific size. And they're not always at even intervals, like a ½ inch or a quarter. Some of our drills are .207, for example, on the next job. That's called a number 7 type drill. And that you'll read about in hole making slides. But now we have a bigger tool, so we're going to need to slow this down a little bit. And I'm going to run it at 250 RPM. I'm just using the low range. The bigger the tool, the slower your spindle. So if we have really tiny drills, these spindles are going to be running at about 1,000, 1,200, 1,500 for some jobs. If we have bigger ones like this, and there's a specific formula that you're going to learn about called the speed and feed formula that will tell you what RPM you should be turning. I'm just going to kind of guess that this is a pretty good RPM, being that we're holding it with a floating vise. So we want to gently come in. Again, let the drill find its place by just butting it in, and now just applying a gentle pressure and pecking your way through. You can tell the drill is ground nicely. You see there's two even these little chips are coming off of it. Remember, don't get your finger near those. They're really sharp by now. But if you saw, there were two of these things, and they're hot too, by the way. Two of these things coming out. That means this drill, the lips of the drill are ground absolutely perfect. If it were one side were bigger than the other, you would only get one big, long, ugly one and then a nasty little scraggly one. These are both the same, and that's kind of a telltale sign that the drill is in really good shape. And that it's actually cutting as I'm going deeper. A dull drill would not give you a nice chip like this. It would fight you. And that's just something you'll develop by time. You'll actually use the drill and you'll say, oh man, I'm pushing and pushing and this thing is absolutely not giving. So another thing you look at that is a telltale sign, and now I'm getting through to the bottom, you slow it down, and then you break all the way through. And we're done. What you also want to look at is, and always be cautious, because depending how much machinery you're doing, look, that was just one little hole. You can kind of watch, there's a real sharp burr on the bottom there, but look at that, that thing is already kind of hot, man. And I mean, we just used a little tool, but here's a burr again, and you'll find a little burr pushed up all along the edges of the hole. So there's a little tool we use when we deburr something. So that's our hole. Now the thing would be to inspect it. So how do I know where the center of that hole is? Well, you can also see, just on getting back to the performance of the drill, you see the inside. It's a little scraped up, but not too bad. That's the finish. A very poor drill, that will be all rough and jagged inside. And you see that this one, it's kind of smooth, and it's not so bad. So this is our datum surface. Now, let's just take this, and what I'm going to do is just take the kit out. We don't keep that in there. I generally ask everybody to kind of take care of the chuck. We'll take our part back to the inspection, and I'll explain how we're going to inspect this. Now what you would also do if you're done with this, you know, at the end of the shift, you can brush the chips into the tray, but then grab one of the vacuums and get those chips out of there when you're done using it. So the tools go back into, we don't have to do it right now, but it's just when it's cleanup time. We got the one vacuum in here, just suck it up in there. And now we're going to go back to our inspection stone, and we'll see how we finish off this part.
Who has it? Yeah, I don't think the reason why people should, you know, take calipers and double check the size. 2 people might be working in one area and then it'll be cleaned up and accidentally grab a bit that was supposed to go in the other kit.
Yeah.
And you end up looking in there and making assumptions and using the wrong drill, but it's just good to double check.
Yeah, and a lot of guys will say, hey, let me borrow that drill, I'll get it right back to you, and they never find, you know, it's like, hey man, this is the kit, you know.
As he was turning, we left, and I was going straight, and it wasn't right in front of me. We did like wait or the gas. So slow.
Okay, so
But his back.
the last thing we want to do, guys, is inspect this part. Did I forget to take the part, or is it
I
in
didn't
here?
see it.
I got it. I got
Put it
it.
in his pocket.
Okay, we talked about deburring, and I have a tool in here, but this is something everybody usually has their own of. It's a little hook, and it's got a really sharp little carbide, and it pivots around like so. What you do is you just kind of put this thing, and then just spin it around the hole, and it takes the edge right off. Biggest danger with this, it looks really harmless, right? I can't tell you how many times I've slipped out and all right, so just, this is one of those tools that you don't think like anything is going to happen, but the minute it slips out on you, you're going to know it because it's going to give you a nice gouge. It's a sharp little carbide bit. And see, now we have a part that's free of any burrs, because in order to inspect it, all the burrs have to be off of it. These should have been filed by you, so you should have had no burrs here. When you saw cut it, you will have had a burr, and then when you guys hand filed it, you also knocked off the edges, I hope. And now this part is completely free of burrs. So now we can go ahead and inspect it. So what do we look for? Well, getting back to this drawing, you'll see that we have our datum edge marked, right? Is that in frame? You seeing it? Yeah. So that datum edge is marked. That's this corner here. So if we want to measure the center line of this hole, all we really have to measure is from here to there, right? And so what would that be? At the lowest point, right at this little witness line right here, this distance would be, whatever that is, 1 inch minus the radius of the hole. Radius is half its diameter. So 1 inch minus 0.25 would give us, from this very edge to there, ideally 0.75. With me on that? That's another metrology lesson you're getting for free right now.
Not too complex.
So the way you do this is you kind of leave a little pressure on your see, look where I'm at, 0.748. That's good. That's really good actually for me. Also, you want to validate and verify that your hole is a 1/2 inch in diameter. See how it's, so otherwise you're not using the right formula, right? I mean, if the hole's not actually 1/2 inch, this number is going to be different. So, likewise now we have 0.75 minus 0.25. That means I should be what from the top? 0.5. I'm actually at 0.498. So my hole location is 2 thousandths too far that way and 2 thousandths too far up. Is that within tolerance? Is this is, yes, because our tolerance is 1/64th, which means 0.015. That's it. How's that? Any questions on that? Okay, well, I'll leave this out here. Generally, these are in the tool room. But if you want to work on this today, you guys, I'm going to leave this out here. I'll be around, of course, so I'll leave this here, just a sample there. I'll leave that. And I'm going to put this stuff away and let you get to your work. All right.